Okay, so today we are going to start Chapter 5, Section 3, and we're going to be evaluating trigonometric functions. But what we're going to focus on today is SOHCAHTOA. So remember last year, if you had geometry here at McCarthy, this was the acronym that I covered. So the SO that's here, this is for sine, and this would have been the O is opposite, so I'll just write it in here. This is opposite over hypotenuse. Now, if you prefer to memorize it as Y over R, you can do that as well. Now, when you're doing this, let me go ahead and give you a right triangle here. We only use the trig for right triangles, and we're gonna, last year we had the vertices here, or each one of these as the angles as A, B, and C. You will always only do the trig functions for the acute angles, never for the right. So I'm going to go ahead and, for example, you could have done the sine, and they're always going to have an angle here. Now, we've been used to seeing sine as just S-I-N, and that's what you're going to see. But this is what the word that it is associated with that abbreviation. Cosine, COS. So if I wanted to do it based off the acute angle A, when I go to label my sides, in relation to the A, this side is opposite, this side is the hypotenuse, and this side is the adjacent. You always give the name to the sides based off the acute angle they're asking you to do the calculations for. Then for tangent, again, that abbreviation is just TAN. Cosecant is CSC. Secant is SEC. And then cotangent was COT. So cosine, back in geometry, you memorize that. That's the C here. And that was adjacent over hypotenuse. And then what we just learned the other day, X over R. And then for tangent, that where it was opposite, that's the TOA. So that's opposite over adjacent. And yesterday we saw it's Y over X. And then cosecant, that's just the reciprocal to sine. So all you're going to do is flip it. So it's hypotenuse over opposite, or R over Y. Secant is the reciprocal to cosine, so hypotenuse over adjacent, or flip the R over X. And then cotangent is the reciprocal of tangent, and you can flip adjacent over opposite, X over Y. Last year, we've just focused on sine, cosine, and tangent. This year, we're going to see the reciprocals as well. So now we're going to just go ahead and find the 6 trig functions based off of one of the acute angles. So for here, it says to find the 6 trig functions. Now I'm going to add in letters. So I'll put in A here, a B, and a C. I'm going to find the six trig functions for angle A. They could have also said find the 6 trig functions for angle B, never for the right angle. So I'm going to go ahead and label my sides based off of angle A. So based off of angle A, the 7 is the opposite. The 24 is adjacent to angle A. And then this side over here that's across from the right angle is my hypotenuse. Notice it doesn't have a number. So before I can even start to find my 6 trig functions, I need to find the hypotenuse, and I need to do Pythagorean theorem. So in order to find it, I'm going to do Pythagorean theorem, which is a squared plus b squared equals c squared. So the side across from angle A, this is going to be my little a, this is going to be my little b, and I'm looking for c. So I'm going to do 7 squared plus 24 squared equals c squared. 49 plus 576 equals c squared. 625 when I add them. And now when I square root it, my c value is 15. This is actually a common Pythagorean triple. When I teach this to my geometry class, I would tell everyone that this would be a common triple. Thank you. It's 25, not 15. That would have been 225. Thank you, Bradley. Okay, so it is 25, not 15. So now that I have the length of my hypotenuse, it's 25, common Pythagorean triple. Now I can find the values of the 6 trig functions. So if you want to use the acronym SOHCAHTOA, we can do that. And that will give us the 3 basic ones. And then from there, we could flip them to turn them into their reciprocals. So for the SO in the acronym, the S stands for the sine. And we're doing of angle A. So we're doing opposite over hypotenuse. My side that was opposite is 7. The hypotenuse is 25. Nothing to simplify here. That fraction is already reduced. Now, if you want to go ahead, since we don't have an acronym for the reciprocals, as long as you know that the reciprocal to sine is cosecant, just take your fraction and flip it. So now it's hypotenuse over opposite, and this is 25 over 7. You're not going to need to turn it into a mixed number. You're leaving it improper. Next, we'll do the C of the acronym SOHCAHTOA. That is for cosine. So cosine of A, and then the A and the C is adjacent, and the H is for hypotenuse. And then you'll fill in your numbers. My adjacent was 24. My hypotenuse was 25. The reciprocal to cosine is secant. So the secant of angle A, flip that to hypotenuse over adjacent, and that'll be 25 over 24. And lastly, tangent, and that's the TOA in the acronym. So the tangent of A, the O in the acronym stands for opposite. The A stands for adjacent. Fill in your numbers. Opposite is 7, adjacent 24. And now for cotangent, all we're going to do is flip it. So this will become adjacent over opposite, and it becomes 24 over 7. And those are your 6 trig functions based off of angle A. I could also have done based it off of angle B, but you just have to read in the homework which angle they want you to write the 6 trig functions for. Now, remember, if we needed to find that hypotenuse, the other way we could have done it, if you're doing the X, Y, and R, remember, we could have also found the 25 by doing R is equal to X squared plus Y squared and then square root it. So we could have also done it that way, because if you're memorizing the X, Y, and R for these triangles, the adjacent is always X, your opposite is going to be your Y, and then you could fill it in.
So it's basically just like a shortcut, right?
Yeah. Okay, so it's really just Pythagorean theorem, but it's already gotten to the square root part. All right, let's try another example. One more example. Now I'm going to change the numbers on this. I'm going to change this one to a 3 and this one to a 5. Now, for those of you who recognize, here's your common 3, 4, 5 triangle. However, if not, remember the 5, the side across from the hypotenuse is always C. This 3 could be my A, and then I don't know B. So again, I can put in my letters here. Actually, all right, I'll just put it here, and then C. So here, 3 squared plus B squared equals 5 squared. 9 plus B squared equals 25. Subtract 9. b squared equals 16, square root it, and b equals 4. So now that I have all of my sides labeled, now I need to, let's say we wanted to do the angles in reference to angle B this time. Again, it can either be either acute angle, but they're going to specify which angle they want you to write the 6 trig functions for. So here, if I'm labeling my sides based off of angle B, always label the hypotenuse first, and then a side opposite to B is here, and then the side adjacent would be here. So now if I fill it in, the sine of B, and I'm going to fill in my numbers. So sine of B is opposite, if I use your SO acronym, opposite to B is 4, and hypotenuse is 5. Cosecant of B, just flip it, 5 over 4. Then if I did cosine of B, that's going to be the and that's adjacent over hypotenuse, and then its reciprocal is secant, so flip it. And then if I wanted to do tangent of B, then that's going to be the TOA, opposite over adjacent, 4 over 3. And then cotangent of B, flip it, 3/4. So last year we learned about 2 special right triangles. The first one on the left, this one is called the 45-45-90 special right triangle. And notice if you have 2 congruent angles, then we also know that the sides opposite those 45-degree angles are going to be congruent. Last year when I taught this, and you're going to need this for your homework as well, when you get to the 5-3 homework, we also learned last year that the 2 legs were A, and the hypotenuse was A square root 2. Now, as long as the radius or these legs are 1s, you don't need the A. You're just going to memorize it as a 1, square root 2 triangle. And then for the 30, 60, 90, the side across from 30 is 1. The side across from the 60 is the square root of 3. And then the side across from the 90 is 2. Last year we memorized this to be the side across from 30 was A. The side across from the 60 was A with the square root of 3. And then this was just double A, 2 times A. So there is one question in the homework where you need to use the variables. All the other questions, you're just going to use the numbers and no variable. Okay, now, one thing that might help you to remember, this one is called the 30, 60, 90 triangle. And then this one, 45, 45. One way that helps me to remember which one gets the square root of 2 is in the 45, 45, notice there are 2 of the same angles. So that helps me to remember that this one gets the square root of 2. And then in the 30, 60, 90, this one has 3 different angles. Then I know this one gets the square root of 3. Whatever's going to help you to remember. This one has 2 same angles. And then this one is 3 different angles. But again, whatever's going to help you. All right, so the next slide is expecting you to use the special right triangles and find the value of the 6 trig functions for the 30-degree angle and the 60-degree angle. This was actually a test question for my geometry class, and they could not use a calculator. They had to use their special right triangles. So I'm going to go ahead and draw a special right triangle. I'm actually going to draw one here for these 6 questions, and I'm going to label it with the 60, the 30, and I'm going to put in the numbers. Across from 30 is 1, across from 60, square root 3, and then the hypotenuse is 2. down here, I'm going to do the same thing. 60, 30, square root, the right angle, and then 1, square root 3, and then 2. So now, I'm going to label my sides based off of the angle they're asking me to find all of the 6 numbers for. So this one is all for the 30. So I'm going to go ahead and label my sides based off of the 30. So the side that is the hypotenuse is here. The side that's opposite to 30 is the 1. And the side that's adjacent to it is the square root of 3.
Wasn't there?
The picture down here, but this time I'm going to label the sides based off of the 60-degree angle, and my names on the sides change depending on which angle you're talking about. The 2 is still the hypotenuse. The 3 is now opposite, not adjacent, and then the 1 is now adjacent to the 60. So now let's go fill in the values. So for the red, sine, remember your acronym SO, we're filling in opposite over hypotenuse. So this answer, 1/2. It's reciprocal, just flip that fraction, 2 over 1, so the answer is 2. For the cosine, we're doing the C acronym, and this one was the SO. So for the C, we're doing adjacent over hypotenuse, so square root 3 over 2. Now, when we flip it to the secant, I have to rationalize. I can't leave that square root of 3 in the bottom, so I have to multiply. And the secant of 30 is 2 times the square root of 3 over 3. For the tangent, we're using our TOA. Opposite over adjacent. Again, I got a radical in the bottom, so I have to rationalize. Multiply top and bottom by square root 3, and you get square root 3 over 3. Now, instead of taking the final answer for cotangent, I'm going back to what it was when I put it in originally. Because if I just flip it, then I don't have to rationalize. But if I would have used this answer and then flipped it, then I would have had to rationalize. So I'm going to go back and take what I had originally put in, the opposite over adjacent, and then flip it back to adjacent over opposite. So again, same acronym, but now my labels on my sides have changed because they're in relation to the 60, not the 30. So again, sine is SO, opposite over hypotenuse. And then when you flip it, I got to rationalize again. And you get 2 square root 3 over 3. Then cosine, that's the C. Adjacent over hypotenuse, 1 over 2. Flip it for secant. And then tangent, opposite over adjacent. Simplify. And then here, flip it. This time I got to rationalize this one. And then square root 3 over 3. Now, last year you learned that the sine of one acute angle is the same as cosine of its complement. Because if you notice, these answers that here were for sine and cosecant are the same as cosine, its complement. Because remember, complementary angles add up to be 90. And then the same thing here, the cosine of 30 is the same as the sine of 60. Then the other one was the 45-45. So let me go ahead and draw that in here. Now, for this one, it doesn't matter which 45-degree angle we're talking about because they both have a value of 1. So it really doesn't matter. I could go ahead and label my sides based off of this 45. This is opposite, adjacent, and hypotenuse. And now I'll just fill in my numbers. So again, sine is the so opposite over hypotenuse is 1 over the square root of 2. I have to rationalize, multiply top and bottom by root 2, and I get square root 2 over 2. Then if I flip it to its reciprocal, for cosecant, it's now square root 2 over 1. I'm using the original, and then I don't have to rationalize again. For cosine, it's exactly the same thing, because adjacent is the same as opposite when it's 45, 45, and hypotenuse is the square root of 2. Rationalize, and it's square root 2 over 2. Flip it, square root 2 over 1, square root 2. And then lastly, tangent, opposite over adjacent, 1 over 1. Same thing for cotangent. So this was the ka and the toa. Now, last year, if you remember, one way to check that your calculator is in degrees, I would always tell my class to put in their calculator, tangent of 45. Once you hit that button on your calculator, if you don't get 1, you're not in degrees, you're in radians. If you get a crazy long decimal. So this is a good fact to remember, that the tangent of 45 and the cotangent of 45 equals 1. This is going to help tremendously when we switch to radians and to degrees, because what happens with the graphing calculators, once you do those buttons to clear your calculator, the default for your calculator is radians. So I've had a student who ended up taking the test, and it was supposed to be in degrees. They did all the calculations in radians, and they failed the test. Because once everyone cleared their calculator, I told everyone, check your calculator, make sure it's in degrees. But that student did not listen, and that student failed the test because all their calculations were wrong because they didn't check their calculator. So make sure you're listening and you're following directions, especially when we get to take this calculator portion of the test. The quiz on Monday is no calculator, okay? You're gonna get the reference sheet. Actually, no, I take that back. It is calculator, because all you're having to do on this quiz is really multiply and divide by 60 and 3,600. So yes, it is a calculator test, and it's also a reference sheet.